Good afternoon, everyone. Thanks for coming to my presentation. I'm super excited to share with you today the quest for Omnioculars, embedded visualization for augmenting basketball game viewing experiences. I want to thank the VIS committees for the Honorable Mention Award, and of course, my wonderful collaborators, Zhutian, Yalong, Daniele, Johanna, and my advisor, Hanspeter. So if you come to this talk because you are a Harry Potter fan, this slide is for you. Omnioculars is originally from Harry Potter, which is used for a Quidditch game. It is a magical object that provides the fans with the ability to see everything during the game, such as play-by-play breakdown or replay. Because you can see everything with the Omnioculars, we ask, why not data visualization? So we took this inspiration and studied the design of data visualization for watching basketball games. So what our paper is about, we present a design study on interactive game viewing with embedded visualization for basketball fans. Our vision of the future sports game viewing is people can interact with the game video in real time, analyze data through embedded visualization, and have a better game understanding and engagement with these augmenting game viewing experiences. Therefore, in our study, we adopt a user-centered design approach. We frame the problem with a formative study, then propose a design framework to support the design of embedded visualization in the sports game, and then build an omniocular prototype with 5 embedded visualizations in a simulated game. And finally, we evaluate it in a user study. In this talk, I will briefly walk you through our design process and share the key findings from our user study. So you might ask, why basketball? To start with, I want to provide you with a little background about the NBA basketball game data. We focus on basketball because it is a popular team sport with large fan bases, and also it has provided many publicly available data to the audience consistently over the past 5 years, such as live box score, game events play-by-play, and even the location tracking. And this leads to many fans actively involved in data analysis during and after the game. However, this huge amount of data doesn't seem to help fans in the live game because current visual analytics system many target expert analysts and journalists, and most of them focus on post-game analysis. And data provided on the TV is also purely simple, static data and cannot be personalized. And therefore, if fans want to consume more personalized and advanced data during the game, they have to look up online, which distracts from watching the game. Thus, we found there's a current gap in providing data to support fans in game data analysis. To achieve our goal of designing interactive embedded visualizations to support sports game viewing, we break down our research into 3 research questions. First, what do fans desire in a live basketball game? Second, what are design considerations for embedded visualizations for live game videos? Third, how well do embedded visualization actually help users enhance game understanding and engagement? To understand the current situation and pain points, we conduct a formative study with basketball fans. We first design a user experience survey. We ask fans to watch an NBA game and take a note on the moment when they want to know some data. For example, a casual fan wants to see the 3-point shot percentage when he saw a player took many shots. Another fan wants to see the lineup performance when he see the odd lineup was in place. We further interview 6 fans on their game watching experience and record them watching an old game and think aloud. So in total, we collect 103 data-seeking moments from fans and perform thematic analysis. So in conclusion, we found that there are diverse game contexts where fans want to look up different data, and current data provided on TV lack diversity and controllability, and looking up data online is distracting. Therefore, to tackle this problem, we propose to design embedded visualization in the game videos. We first arrive a design framework for embedded visualization that takes context into account. Based on our coding results, we categorize 3 components collectively forming a context, including a scenario, a task, and data. A simple example could be when Joel Embiid fouled, the user wants to identify the foul number of Embiid. This context of data need then drives the design of the embedded visualization. But with so many possible game contexts, how can we decide what context and what embedded visualization to design? So this leads to our second step, a design exploration based on our design framework. We first came up with 20 design sketches based on the context mentioned by the fans, and then worked through the design with 6 fans to prioritize 5 representative design contexts. Let me show you some example sketches we had during the design process. The most mentioned scenario was when a player shoots, fans want to identify and compare the box scores of players, so we propose overlaying shot label on top of the player. And also when the defense team had a particularly good or bad performance, fans want to track the distance between the players. So we propose to show the location and defense zone of defenders. By showing multiple design mockups, we gather feedback on what visual encoding provides more helpful information for fans. Our next step was to develop this design in the actual game context. Because of the difficulty in embedding this visualization accurately onto the actual game videos, we create a simulated game in 3D environment based on the publicly available NBA data, including player tracking, box scores, and shot location data. Once we have this simulated game, we iterate on the 5 embedded visualization designs further with 2 diehard fans and implement our Omnioculars prototype. So I will introduce each of our 5 embedded visualization next. Our first visualization is shot label. It shows the shooter's shot performance after shooting in a static label, and also show players' shot opportunity in a dynamic label, which shows the location-based shot percentage of the player with the ball. And second is the offensive trajectory. It helps fans identify players' movement through the player trajectory and compare players' open shot opportunities with the circle size under the players. The bigger, the better, the more open. And the defense forms highlights the ball defenders in blue, and it helps fans evaluate how efficient the defense teams are performing. And the shot chart allows fans to have an immediate peek of the players' in-game performance. So it shows players' game stats, their shot attempt, and also their average shot percentage by zones compared to the NBA average. Red means hot and blue means cold. And finally, team panel compares 2 teams' in-game performance. It highlights which team has a better performance and overall shooting compared with the NBA average. We conduct a user study with basketball fans to evaluate our embedded visualization designs. In part 1, fans analyze a simulated game with each of the 5 embedded visualization. And in part 2, they use the entire set of visualization to watch game and think aloud of their observation. We collect their oral feedback and subjective rating. So let me share with you some of the results. First, 5 embedded visualization were found to be easy to understand, helpful, fun, and novel by the majority. Furthermore, each visualization helps fans to analyze different game aspects. For example, with the shot label, a fan observed, when I see LeBron James drives, the color changed drastically, so I get that why he did not make the 3-pointers and try to take the drive. Overall, we found users can derive useful game insights from using the visualization and interaction provided by Omnioculars. Here's this example of how fans interact with the Omnioculars to derive game insights.
I want to see shot label and team panel. It's so interesting to see the shot percentage climb up as they drive to the basket, show offense trajectory and defense form. This guy right here is wide open. And shot chart? Yeah, I can see J.R. Smith is having a good game. Hide shot chart?
A key point I want to highlight is we also found that participants use different visualization in different ways. They choose to combine different visualization to help them observe the game. So for example, half of the people configure a fixed set. P6 particularly chose 3 visualization to help him focus on certain game aspects and stick with them for the entire game clip. The other group of users altered the selection based on context. a participant first use offense and defense to understand the team drills, and then switch to the shot label to focus on shot selection. Therefore, we discuss how future embedded visualization should be flexible and interactive to accommodate different fans' needs, and the opportunities to extend this beyond the screen also provide exciting opportunities. For more discussion and future work, please see our paper. Thank you so much.